Welcome to the second video in this series of introducing mass relationships in chemistry. In the prior video, linked in the description below, one saw that chemistry is basically an algebraic science. In other words, everything comes down to ratios. Most fundamentally and most importantly, you saw that the mole was the ratio of the number of atoms one has to the number of grams that one measures out. One also saw that a chemical formula is the ratio of the moles of an element to the moles of a compound. In this video, we'll look at mass relationships in reactions, because after all, atoms and compounds are rather boring if they don't do anything. In a chemical reaction, the mass relationship is determined by something called the balanced equation. The balanced equation is the ratio of the number of moles of reactant to the number of moles of product. It's important to note that in a chemical reaction, one very simply is breaking old bonds and forming new bonds. You're rearranging the elements that one already has. Nothing is created or destroyed, and in a reaction, mass is conserved. So, looks at a chemical reaction. As written, this is a qualitative statement that aluminum 3 oxide will react with barium to make aluminum metal and barium oxide. However, the ratios are not balanced. To do this, one very simply goes element by element from left to right. So, starting from the left, the first element one sees is aluminum. There's 2 aluminums on the left, 1 aluminum on the right. Therefore, to balance this, one needs a second aluminum on the right. The next element that's showing up is oxygen, with 3 on the left and 1 on the right. This is a key point. The oxygen on the right is part of barium oxide. One does not change a chemical formula when one is balancing an equation. Barium oxide has a ratio of 1 barium to 1 oxygen. So to get 3 oxygens, one needs 3 moles of barium oxide. By changing this, one also changes the ratios of barium. There are now 3 on the right, but only 1 on the left, so I would need 3 bariums. So, when the qualitative reaction is balanced quantitatively, it says that 1 mole of aluminum oxide will react with 3 bariums to get 2 aluminums and 3 barium oxides. Moving on to a more complicated reaction. C6H12O6 will react with oxygen to give CO2 and water. This is the basic chemistry of metabolism, as everything is created, turned into sugar as food, and burned with oxygen to give energy. Once again, going from left to right, I say I have 6 carbons on the left, which means on the right, I'm going to need 6 CO2s. On the left, there are 12 hydrogens, which means to get 12 hydrogens on the right with water, I would need 6 moles of water. The final element, oxygen, is in 4 places going from left to right. If I look on the right side of the balanced equation, I have 6 CO2s. Each one has 2 oxygens, so that's 12. 6 waters with 1 oxygen is another 6. So on the right side, I have 18 oxygens, which means on the left side, I also need 18. C6H12 provides 6. So the question is, how many oxygens are going to be needed to provide 2? And the answer is 6 moles of oxygen. To use this reaction, you now enter something called stoichiometry. How to use a balanced equation in the real world to get a mass relationship. For example, if I wanted to produce 18 grams of CO2, how many grams of C6H12O6 would I require? One starts with looking at the known. I have 18 grams of CO2. Anytime one sees something in grams, one immediately converts it to moles. So in this case, I have my 18 grams of CO2, one carbon weighs 12, each oxygen weighs 16, so 2 times 16 plus 12 means CO2 weighs 44 grams per mole. Noting, by dividing, grams are going to cancel out, and I'm left with 0.409 moles of CO2 as a starter. I compare this to the unknown, and I compare it through the balanced equation. I know I have 0.409 moles of CO2. The balanced equation says I get 1 C6H12O6 for every 6 CO2s, meaning I would get 1/6 the amount of 0.409 moles, where the CO2 cancels. So to produce 0.409 moles of CO2, or 18 grams, I would need 0.068 moles of C6H12O6. Finally, to answer the question asks how many grams, so one now has to convert moles back to grams. In this case, I multiply the number of moles by the weight of C6, 6 carbons, 12 hydrogens, 6 oxygens, weighing 180. I'm multiplying because moles times grams per mole is going to cancel out the number of moles, and leave you with my answer. It would take 12.27 grams of C6H12O6 to produce 18 grams of CO2 by this balanced equation. So essentially, balanced equations are the ratio of the moles of reactants to the moles of products. Stoichiometry is a way to use that relationship to convert moles into something measurable and useful, and measurable as grams. You will see in the next video, linked in the description below, that no reaction can go on forever. So in this particular case, I'm either going to run out of oxygen or sugar. The question to be addressed in that video is, how does one determine which reactant runs out first and how much product you can make? That is linked in the description below once again, and I hope you found this short video useful, and thank you for listening.